Hello Honors Math 2, thanks for tuning in. I know this is going to pain you, but this is my last video. This is our last video of the year, so thanks for keeping up and thanks for watching and thanks for doing all of your homework. I've found in my teaching career, if you ever have an extra day, factoring practice. So here we are. Let's spend a day with a little bit of factoring practice. It will help you immensely for Honors Math 3. So take some time on this factoring. Let's see, we're going to start with easy factoring, and then this gets kind of tough. Remember how to factor something like number 3. You're looking for two numbers that multiply to equal negative 24, and two numbers that add to equal 5. And remember, you're undoing the multiplication. That's what factoring means. You're asking yourself what two things multiply together to give you that trinomial. X times x would be x squared. What times what would equal negative 24? Notice that if this is negative, your signs have to be opposite. So I know the signs of my factors are opposite signs. And we have to add to equal positive 5. So I'm going to use 8 and negative 3. And this factors to x plus 8 minus 3. You can always multiply to check. You don't have to. But when in doubt, you could always FOIL this back out, double distribute, and you'll get that back. Alright, so it only takes a moment. You can always multiply out to check. Look at number 5. It helps to pause this video and try it on your own if you can. But I'm going to factor number 5. What could I undo? What would multiply together to give me that? Factoring and dividing is the same thing. We're going to divide that into two binomials. Of course, this would be x and x. Notice since that last term is positive, I want two numbers that multiply together to give me 8. The signs have to be the same in order to multiply by a positive, but then they have to add to a negative, so signs have to be the same and they have to add to be a negative, so they both must be negative. Hopefully you found negative 4 and negative 2. I do want to make a note for all of these. When you practice factoring, you can write those factors in either order, so you might have written x minus 2, x minus 4, perfectly fine, because you can multiply two numbers in any order and you get the same result. Alright, so either one of those is fine. You can always FOIL and make sure that you're right. I'm going to move down to number 9. Take a look at number 9. I'm just doing a sampling of problems in case you need a little bit of a review or some tips or pointers, and then you're going to finish up the rest for homework. Look at number 9. How would you factor this thing? At first glance you say, oh, that's the trickier factoring because there's a coefficient of 2, which you would be correct, except that all three terms are divisible by 2, so I'm going to take that 2 out first. If I factor out a 2, that means divide everything through by 2. Keep that out front because 2 is a factor, so I factor out a 2, but I'm left with x squared plus x minus 12. Again, it's very important. Keep that 2 out front. That's one of the factors, but now I'm going to unfoil the rest. Two numbers that multiply to equal negative 12, same two numbers that add to equal 1. You can always pause and find those on your own. But my two numbers are what? Positive 4 and negative 3. And that thing is factored completely. Alright, now our factoring really picks up. Alright, so let's continue. I have a common factor in each of these three terms. Please notice that I can take out a 5. Oopsies. You can take out a 5. You can also take out a y. Let me rewrite that. I can factor out a 5y. What am I left with? Take out a 5y, and I'm left with x squared, minus, take out a 5y, what is that? 6xy, divide by 5y, and I'm left with positive 8y squared. Okay, this looks kind of crazy, but I can factor this thing that's left. Again, keep your 5y out front because that's one of the factors. What times what is x squared? That would be an x and an x. What times what is y squared? That would be a y and a y. Then I still want two things that multiply to equal a positive 8. Same two numbers that add to equal a negative 6. Okay, signs have to be the same since that's positive. Minus 4, minus 2. So even though that looked horrendous, not so bad when you dive in. Again, keep that 5y because that's one of the factors. You should be able to multiply all of this together and get that original thing back. I'm not going to do number 12, but I'm just going to give you a little hint on number 12. Always factor out a negative. We hate to factor when there's a negative leading coefficient, so even though you notice you can take a 4 out of each term, actually take a negative 4 out of each term. Is there something else? Yeah, that y again. So negative 4y. See what you're left with when you divide by negative 4, y, and then factor again. Alrighty, so you can try that one on your own, but definitely factor out the negative to make that leading coefficient then positive. I do want to look at number 13. It looks strange, but it's actually easy factoring because this term and this term match. I don't know if you can see that, but that's basically like a squared minus 2a minus 35. Like if I asked you to factor that, you could factor that no problem. That thing and that thing match. That thing and that thing match. So actually this is not difficult factoring. I'm going to unfoil. What gives me 3x minus 2 squared? That would be 3x minus 2 times 3x minus 2 would be 3x minus 2 squared. What multiplies together to give you negative 35 adds to give you negative 2. Again, if you were asked to factor this, you would say no problem at all. And those two numbers are what? Negative 7, positive 5. Okay, notice you can combine some like terms in those parentheses. That's 3x minus 9 times 3x plus 3. But now I notice I have a common factor in that first term, so I can factor out a 3. And I'm left with x minus 3. But then for that matter, I have a common factor in my second term. I can take out 3, and I'm left with x plus 1. Certainly I would multiply. 3 times 3 is 9 as my leading coefficient. X minus 3 times x plus 1. Some of you will whip through this factoring practice. Some of you it'll take you a long time. I'm saying turn in your homework by Friday. I would rather you turn it in over the weekend late than turn it in Friday and not do it seriously. So take your time. If this takes you a while, turn in your homework when you're done with it. I just gave you as a goal on Friday. Alrighty. I'm going to move to, let me look. I'm actually going to move to number 20 just because I have a little space by number 20 and then go backwards again. Remember the AC method? This is a tougher factoring when I have a leading coefficient that's not 1. So I'm going to use the AC method. And I say A times C is equal to what? That's saying AX squared plus BX plus C, something in that form. When you multiply A times C, 5 times negative 4 is negative 20. We'll do another one of these. And B, which is that middle coefficient, which is 8. Now I want to find two numbers that multiply together to give me negative 20, add to give me 8. 5 and 4 don't work. I can't get an 8 out of a 5 and a 4, so I'm going to use 10 and 2. I can get an 8 out of a 10 and a 2. This sign tells me that these signs have to be opposite. This sign tells me that the larger number has to be negative. When I combine 10 and negative 2, I get 8, and that works. Then remember, I separate that middle term into those two terms. So I'm going to rewrite this original expression as 5x squared plus 10x minus 2x minus 4. The cool thing about this little grouping is if you rewrote this as negative 2 and 10, negative 2x and 10x, you'll get the same thing. It's fantastic. Alrighty, so let me see. Now I factor by grouping. What can I take out of those first two terms? A 5 and an x. And I'm left with 5x divided by 5x divided by 5x plus 2. I group these second two terms. What can I factor out of those two terms? A negative 2. Divide by negative 2. Divide by negative 2. Factor by grouping works if those end up being the same. Okay, what does this become? Out of the first term and the second term, I can take out that common term of x plus 2, and I'm left with 5x minus 2. And that's completely factored. Beautiful. All right, you're going to try these a few times. These probably take you the most time. Alrighty, so again, take your time on your factoring. It's fantastic practice. I love all of these. This is a good one that I found. I'm moving back to number 17. Go back to number 17, pause the video, and try to factor that. AC it if it helps. Some of you are good guess and checkers. Just guess and check it and unfoil it. But I'm going to AC it. Okay, A times C is positive 9, B is negative 10. My two numbers that work, multiply together, give me 9, is negative 9 and negative 1, combined to negative 10. So I rewrite 3x squared minus 9x minus 1x plus 3. Factor by grouping, 3x times, what is that, x minus 3. Take out a negative 1, left with x minus 3. Now I have a common factor in both of those terms. From this and this, I'm going to take out an x minus 3, and I'm left with a 3x minus 1. And there you go. You could always FOIL that out and make sure you get that original expression. I'm not doing number 18, but look at number 18. It looks like an AC method. Until you look closer, notice there's a common factor of 3, so I'm going to take that 3 out first. I'm left with x squared minus 10x plus 25. Actually, I'm going to continue on this. Alrighty. Now this factors, and it's easier factoring, so I keep that 3 as a factor. X, factor that thing if you would. Minus 5, minus 5. The reason I want to finish this up is I would actually write that as 3 times x minus 5 squared. Solutions are at the end, but just be honest with yourself so you can try them before you look at the solutions. Alrighty, I even found mistakes in the solutions. So you can be smarter than the solutions. Alrighty, I'm going to skip to number 27. Please find it. Look at number 27. Do you remember we called that the difference of squares pattern makes that middle term, that B term, cancel out? And anytime I have a perfect square minus a perfect square, factors 2, x plus 10, x minus 10. If you don't believe me, FOIL that out and make sure you get x squared minus 100. Alrighty. Use that pattern though. Look at number 30. Looks complicated, but it's something squared minus something squared. So it's my difference of squares pattern. Take that. What squared gives me 3x plus y squared? That would just be 3x plus y times another 3x plus y plus 3 minus 3. Ha! It's factored. So watch for that difference of squares pattern. Nothing combines, so I have to stop there. Look at number 32 and start to factor it. Perfect square minus a perfect square, so it's a difference of squares pattern. 2x minus 3, 2x minus 3, plus, minus. It's just I have to be careful of this term. This is 3x plus 2. This is 3x plus 2. Just notice for this second term, that negative is going to change the signs. So I have to be careful of those signs is all. In this first parenthesis, that addition will not change the sign, so I'm just left with 2x plus 3x, which is 5x minus 1. Here I'm going to distribute that negative, 2x minus 3. What is that? Minus 3x minus 2. Combine like terms, we never leave that negative in there. So I'm going to factor out a negative. Take out that negative, which switches your signs. Look at 34, try to factor it. It's not too bad. Here to get y to the fourth, I'd have y squared and y squared. To get 72, Just notice that first quantity factors.